Okay, the time is about 7 p.m. over here in Taiwan. So good evening, everyone. My name is Seng Chee. Together with Alwyn, we're the moderators for this session. This session is about AI and analytics for collaborative learning and knowledge building. And we're very glad to have with us Leanne, Chee, Bodong Chen, and Mutlu CUKUROVA with us today to share with you some of the works that they've done in terms of AI and analytics for collaborative learning or knowledge building. And Alwyn, you want to go through very quickly the next few slides?
Sure, thank you. And so just give a brief overview of what we are looking at today for this panel session. It's a very short 1-hour session. We're actually looking at AI analytics together used for collaborative learning and also knowledge building. And so some of the panelists will be touching on certain aspects of this. And more importantly, we are looking at how we can study the use of such AI analytics to interpret, monitor, and support students' interactions in CSCL context. So CSCL, as you can see on screen, is computer-supported collaborative learning. And also this has been extensively studied in knowledge building environments, or you'll hear more later, what we call KB. And this panel discussion is going to showcase and also highlight some of these works and the use of analytics. And of course, within an AI conference itself, we also talk about further enhancements using AI. And so the structure of this whole session will be having a panelist. Each panelist will be speaking for 5 to 10 minutes. We will then reserve the last 20 minutes for Q&A. So if you have questions at the moment, please hold on to them, or you can share with them on the CUKUROVA app or on the Zoom chat, and we will actually refer to it later. So just to give a brief overview of the panelists who will be joining us today. Of course, before that, let me describe. Seng Chee Tan is actually Associate Dean in the National Institute of Education, Nanyang Technological University. I'm also with Seng Chee at NTU Singapore. So our panelists, we'll start off with Leanne. She's from Ontario Institute for Studies in Education. She's from the University of Toronto. Followed by Chee. She's actually a Senior Education Research Scientist and a Program Director of Learning Sciences Innovation Research Program. She's from the National Institute of Education, Nanyang Technological University, Singapore. Followed by Bodong Chen, who's an Associate Professor from the Teaching, Learning and Leadership Division from the University of Pennsylvania. And then we have also Professor CUKUROVA from Associate Professor from UCL, University College London. And so without further ado, Seng Chee, do you have anything that you want to add on at this point?
No, I think we can just start now. Let us invite Leanne to start the presentation. Leanne, please. Thank you.
Good morning, everyone. Can you hear and see me? So I wanted to start off today's session with some big questions around the goals of education and how we can redesign education to empower learners with AI. So a child starting school today will actually be entering the workforce in a world that is 20 years from now. So what would that world look like, and what type of skills would that child need to not only survive, but thrive in their everyday life? And so policymakers, educational researchers, and educational experts have been examining these issues over the last few years, especially with the many changes brought on by the pandemic. And you can see these are a variety of issues that the children will be facing as identified by the OECD back in 2020 with notably artificial intelligence bringing about the largest amount of uncertainty and the largest amount of impact in future societies. And regarding the second question, the World Economic Forum identifies future learning skills that students would need in upcoming years. And this is the latest one from 2020, where they predict that by 2025, these would be the top 10 skills that students would need to thrive in the workplace. And you can notice that they're quite similar to the general 21st century learning skills, critical thinking, problem solving, creativity, innovation, and so forth. And they've actually listed technology use, monitoring, and control, as well as technology design and programming towards the bottom of the list. And so within the context of today's talk, I'm going to try to encourage us to think about how technology can be used to enhance these skills, and as well to open up opportunities to develop new skills for learning and for work. So in the first example I provide, it's about students in grade 3 in Ontario using learning analytics for collaborative learning and collaborative problem solving. And in this example, they wrote a lot and they were using multimedia and drawing tools and videos to examine photosynthesis over the course of a few months. And students use different analytic tools such as the social network analysis to look at their contribution patterns and how they built on and read other students' notes. They used a bar graph to look at the different ways in which they enhanced the collaborative discourse. So the different sentence starters would be like my theory or new information or I need to understand or putting our knowledge together. So they looked at both individual and group level profiles to look at how their discourse was moving forward and what moves they needed to advance their collective knowledge. And on the right-hand side is just a word cloud, which we can find in many online platforms today. And so what was interesting as well was that the students were pretty critical about what these tools would display, because even though they were meant to convey transparent online behaviors, for example, the social network tool, students were able to reflect that the more you contribute, the bigger size your node is. And so it doesn't necessarily represent the quality of the discourse. And in a similar way, for the word cloud, the more common a word is, the bigger it is, and not necessarily the most important, the more important the word is. So these are inherent biases in certain online learning analytics that we can then use the feedback for to improve future iterations. So in the second case, it was between students in grade 6 collaborating online, students in Ontario and Mexico, and they were collaborating before the pandemic, and halfway through, their conversation shifted when they went into remote online learning. And so on the right-hand side, they use the social network analysis tool again, and in this context, you can actually see how students in one country collaborated with students in another country. On the right-hand side, it just shows that one student in Ontario and one student in Mexico contributed relatively evenly, which suggests a more fluid exchange between the different classes. And specifically with the context of the discourse, when they were sharing their experiences about the remote learning and learning from home, you can see the sentiment analysis of their online discourse on the right-hand side with the less happy words in red and the more happy words in green. And what was interesting was that initially they were sharing a lot of anxiety and nervousness around the situation, but then when they went and read each other's notes, including students in different countries, they were then offering each other comfort and being very compassionate, hence the green color coming up at the end. So it was really interesting that this was happening as kind of a natural process of community building and also being compassionate toward each other. And then this is just another comparison of when we were building community at the beginning of the year, and they were just sharing different cultural experiences of how the two groups of students celebrated Christmas in Canada versus Mexico. And here as well, we see a bit of machine learning bias where cold is negative, but in this context, the kids were excited to learn. The kids in Mexico were excited to learn about snow because the kids in Canada experienced snow during Christmas, and as well Spanish is in red, even though the kids were trying to learn different keywords of Christmas in different languages. So here as well, even though it helps provide enhance the picture of online learning, there are some caveats when we're reading these online tools. And in the third case, this was with a collaboration with a big project done in Singapore where many students in middle school would come together online for a design studio. And this happened over the course of a few years. And I think within the context of the example I'm providing, the kids were engaging in playable analytics. So the analytics were actually more interactive, where you can select things, you can change things, you can remove things to see patterns that are there, but patterns that are also not there. And so we tried to take the analytics to the next level by not only having the students analyze their own discourse on their discussion platform, but also to use analytics to analyze authoritative sources online. So within the context of this work, they were studying climate change, plastic pollution, and endangered species of animals and food waste and food shortage. So what was really neat was that the students' questions were quite similar to the questions that Google recommends that a lot of people search when they look up certain keywords. And then we imported those keywords into the Google Trends to then compare how people in different countries have talked about these issues, and as well how these issues have been talked about historically. So as you can imagine, there's a lot more data on Google than in a specific textbook or in a specific online platform. So through analyzing the data online, the students then brought back new information, but information that was kind of transformed and kind of pre-analyzed before bringing that back into the whole group discussion, and that really helped push their thinking forward. So these are just kind of preliminary works with additional analysis to be done. So bringing back to the larger question of what skills will the children need to not only survive but thrive in their day-to-day lives. Well, of course, we need the 21st century skills, but we also need a vast range of new skills like cross-cultural collaboration, collaborative problem solving, information literacy, digital citizenship. And I remember last year, someone at the Empowering AI conference mentioned human and AI collaboration, but it still hasn't been identified by World Economic Forum, but a lot of AI experts and people in the workplace have already been highlighting the importance of human AI collaboration. So that's something to think about. And in the final note, I also want to encourage everyone here to think about what type of world do we want our children to enter. And so in addition to climate change, the pandemic, artificial intelligence, we've had new issues to grapple with that have been brought to light in terms of their severity, like racial injustice and the infodemic online. And so AI both plays a role in not only accelerating the issues, but also potentially designing better solutions to help us address these larger societal issues that affect all countries. So I just wanted to leave it there and pass on to Chee. Thank you.
Thank you, Leanne. Let's hear from Chee right now. Next, Chee, I think she'll be presenting on knowledge building as well. Chee.
Yeah. Can you see my screen? Is it the full screen?
No, we're seeing your notes, presentation notes.
Okay.
Yep.
Yeah.
Thanks.
Okay. Yeah. So just building on what Leanne talks about the knowledge building, we look at a set of try to develop a set of multimodal learning analytics to look at students' social emotional engagement. So this was our aim, because we know through their participation and learning, we want to derive their social emotional engagement as well as some of their physiological behavior. And so just this is how we look at knowledge building. This has a lot of implication in our work because as we were designing the activity, we wanted to look at how students' idea developed from the idea generation phase to the idea improvement phase. Later on, you'll see some part of the data showing you how we have the different phases of knowledge building so that we can identify the different processes that were happening during knowledge building. But mainly, we were drawing from this collective idea improvement, from creating, sharing, building, connecting, to improving ideas using the data from Knowledge Forum, and of course, building the design around the knowledge building principles. And so this is, I think, I do not need to go into much detail. This is how the knowledge building threaded discourse work, where students are building on each other's idea. And each of the node itself, students has the scaffold. They will use the scaffold and they will write their node content, because then we are part of our analysis revolve around a lot around the knowledge forum nodes. And so with this in mind, okay, this is how we actually build our multimodal learning analytics. We have the 3 sets of data, the video data, the from the physio sensor, and our knowledge forum discourse. And what we do is we extract different sets of features from the data. The video data, of course, is the richest, where we have pose and the facial and hand gesture. And from the physiological sensor, we have the EDA, and knowledge forum, we have text and ideas. So from these features that are extracted, we look for patterns and sequence, and this we work with our industrial partners. So what Leanne was talking about in our design studio, we have to move it into an online virtual environment during the COVID-19. So a lot of this work was done via Zoom, but later on I'll also show our face-to-face interaction. And from here, with the different patterns and sequencing, yeah, I forgot to, let me charge. Okay. So we were looking at the pattern and sequencing and the output where students are showing the different signs of frustration, stress, and we have quite interesting finding about frustration. And of course, this is still at early stage. We are looking forward to, we have some mock-up on the user interface. I'm going to pause for a while to get my charger, sorry. I forgot to charge my battery. I'm going to keep talking while I set up my charger. I'm just going to show also, this is how we set up, because our challenge is to actually look at knowledge building activity in a classroom. So this is how we set up in each of the classroom with a 360 degree camera right in the middle. And then students are wearing their lapel mic with the audio recording and with a general video that is capturing every movement from a broader sense. So this is our setup in the classroom, capturing organically what students were involved in the knowledge building process. And just a quick snapshot to show you how these videos are then flattened to extract the features that we talked about earlier on. So now going into the analysis, I'm just going into is it moving?
No, your screen is not moving.
Yeah. Everything that can go wrong will go wrong. Okay, is it moving now? Okay, so we have this. I'm going to talk very briefly about how we do the manual coding and then part of the model training. At this stage of our work, the hardest part was to look at the fusion of different sets of data, multimodal data that is coming, that is collected in the project. So in terms of manual coding, just a very brief overview. So as you can see, these are the students' ID, and we conceptually worked out. So you can see the different phases of the idea generation to idea improvement, which involve build on from the KF, and then which involve also students working on the rise above node, and then student assessing their data, idea and reflection. So this is important because we work closely with the teachers to develop their lessons based on this phase. Of course, these are still quite artificial because students may be doing build on even at idea generation. But this is how we have unpacked and then work closely with the teachers to design so that at each stage, we can look at the social emotional engagement and based on what the key activity for knowledge building were happening then. So you can see that for each student's ID, they are placed together, and then we have the semantic pattern for the KF notes that we have coded based on the quality of question and explanation. And then we look at their students' self-reported epistemic emotion, which is the 5 colored one. So at one look, you can see that if there are more colors appearing, the students are reporting that they are feeling more emotion at that point. Of course, then this flows in terms of the timeline, right? So once we have this, conceptually, we also map in our physiological data, but physiological data in an authentic knowledge building classroom is quite noisy. So we have to browse through many sets of data just to find some indicator. And you can see that certain points of high physiological data actually doesn't really report what the students were saying about their emotional, their social emotional engagement. So this is the conceptual work that we do in terms of the manual and analysis. At this point, what we are doing is we have created an annotation tool to analyze our video, and we have been testing different sets of data separately. So this is one set that we are showing using the verbal discourse. And so for KF, we have, so this is currently our visualization that we pull out the KF notes, and then from the manual coding of the KF notes, and then the actual predicted level by the machine. So this is the part that we are looking at, the verbal part, the prediction. The fusion part, when we look at the speech of the students and the pose of the students coming together, we are still testing on the algorithm that will actually extract meaningful pattern out of it. So we are continually collecting data and testing the algorithm to give a meaningful fusion index for this. And so the final one, we have a mock-up of how we want to put together students' multimodal data along with their knowledge build, the level of knowledge building. But this, I think this has yet to be achieved. This is just a mock-up to show us how finally we can visualize it. So some of the preliminary finding about frustration, showing sign of more productive knowledge building work. We can come back to this again later when we are discussing. So I'm going to stop my presentation here.
Thanks, Julie. Thanks, Leanne and Julie, for giving us some case example of what they're doing in this using analytics to support knowledge building. Shall I invite Bodong? Bodong, are you there, Bodong?
Yes. Can you see my screen?
Yeah.
Okay, great. Thank you. Thank you, everyone. It's really cool to see the work from Leanne and Julie, and really exciting new work coming out of their research. So I don't have much to say after they present their cool results and analytics. So my presentation will be a little bit reflective to a degree based on the research we have in this community. To begin with, I'm Bodong Chen. I'm from Penn Graduate School of Education. I'm directing a group called Penn Wonder Lab that is doing a lot of technology prototyping and analytics design with partners. So I care a lot about what both Leanne and Julie have presented. And for this talk, I want to begin with, it will be hard to not mention those cool AI that's coming out right now, GPT-3, DALL-E, and GitHub Copilot, and many, many other AI tools that are making their way to the general public and to education. And to me, it's exciting to see them, especially those generative AI apps coming out, and they're super powerful. And I believe they're here to stay. So for educators and for learning scientists, education technologists, a big question is, how do we work with them? How do we incorporate them in different areas of learning and education? So I think so far at this conference, I've heard a few really good many great points and projects coming out. I just want to ask a few questions, and the questions are, what is missing? What is missing in terms of especially what perspectives of learning are not really amplified or are neglected, and what perspectives are amplified or grounding a lot of the discussion and thinking around AI in education, and who is not here. So those questions are coming up for me, and I think I want to maybe spend a little bit of time to reflect on that as we move forward in this work. And as Chee and Leanne both presented, I also work on the area of knowledge building. Knowledge building, as I think, is one example to demonstrate some responses to those questions. As my colleagues have already talked about, knowledge building is a pedagogy, is a theory of learning that cares a lot about students' epistemic agency. And that means it cares about what students think and what students want to achieve in education and learning, and involves them to work collectively to take responsibility of their learning. And to do that, we involve students in design mode discourse, which means the discourse and discussion students have is about how to improve their understanding, how to go further, how to deepen their understanding as they work together. So there's a lot of different kind of work going on. There's a knowledge forum that Leanne and Chee have presented, which is an online space for students to discuss their thoughts. And I worked on a project called Promising Ideas Tool, which involves students to identify promising ideas in their knowledge forum space by highlighting and by ranking and by making decisions about which ideas are worth pursuing. And also did a lot of network science research, using network science methods to analyze this type of social semantic networks, to find patterns and signals from the discourse data so that we can hopefully derive some analytics based on discourse data. So this type of work is emerging and has been going on for a while. And before I talk about any reflection, I want to take you to a quick demo that I was playing with. I've been prototyping some tools recently. I've been playing with some new interfaces for knowledge building and analytics as well. So imagine I'm taking you to a trip to a kindergarten school, and then the students are doing inquiry and learning about fall colors. And once students are coming in, they ask the question, why do leaves fall? Because this is the topic they care about. And then another student come in and say, my theory is it's because the weather is getting cold. And then another student come in and say, but why will leaves fall when it gets colder? So you see this kind of gradual deepening of their questioning and their inquiry. And then another student say we should do an experiment to find out. We put one tree inside to see whether these leaves would fall. That's not a bad idea at all, but it's fixing on this specific idea or question of why leaves change color when it's colder. Another student come in and say, I know because gravity pulls things down. I need to understand, does gravity get stronger in winter? So it's kind of a funny, interesting development of their ideas, not necessarily in the most productive direction, but that's what students come up in terms of making connection with what they know before and try to make sense of this phenomena. Of course, there could be other thread of discussion going in different direction. One student sharing that they realize that the leaves that are falling to the ground are yellow or brown or red. Maybe there's a relationship with the color. Another student kind of have the shared experience. They think, ask the question, they have the theory that leaves fall when they change color. And so they pose another question, why leaves change color when it's get colder. So you see this kind of range of different directions. Of course, there could be many more, as Leanne and Chee shared. The discussion can get complex and rich. But what if we have GPT-3 in this environment, right? what if we at some point involve the student ask GPT-3 by posting the first question, why do leaves fall, and run this on the fly? And then GPT-3 says its most likely answer is leaves fall because of gravity. Gravity is the force of pulling things toward the center of the earth. It is what makes things fall. Of course, every time we ask this question, GPT-3 will respond differently. Leaves fall because they're no longer attached to the tree. So the reason I'm doing this quick demo is to kind of both show you the possible richness of student discussion. Sometimes we see a simple question or a simple phenomenon, and then see how unfiltered or non-sophisticated design of use of AI could be leaving out, right? Could be shutting down a lot of interesting unanticipated directions students can take. So that leads to me to the next part of my reflection is, as we try and integrate AI and analytics knowledge building, I think, or in any other contexts of collaborative learning, I just want to frame a few questions I think it's important to reflect on. The first question to me is to think about what is learning and how does it happen. And for knowledge building, it's apparent that learning happens through engaging with authentic problems and real ideas from students and engaging them in collective sense making. And it doesn't necessarily apply to other settings. So for any discussion of AI and analytics, I think it needs to be grounded in the specific conception of learning. And it's also to recognize the limitation of that conception of learning so that it becomes both grounded and it doesn't deliver a narrow sense or understanding of learning and over promise in terms of what AI can do. And the second point I want to make is to invite us to think about how to position machine intelligence. In a demo, you see the AI is doing a wonderful thing, it's answering a question in different ways. In the same time, it's important to think about how that type of machine intelligence is both supporting student thinking and also in the same time taking things away. In that case, taking the richness of students' creativity away or their natural engagement with each other away. So it's important for us as designers, as educators to reflect on the challenge. It's a big challenge to me to properly position AI to augment student intelligence so that their epistemic agency can be even more retained and empowered so that they can do more with AI in their knowledge building. And finally, I think it's there's a group of us who have been talking about infrastructures in the learning sciences. And I think it's important to think about the surrounding infrastructures as we do this type of work. And assessments comes up a lot because of the connection with analytics. And I also was listening to podcasts of computer science professor complaining about GitHub Copilot and how it has been disrupting their assessment practice. So I think it's important for us to think about both how they're causing disruption for assessment and how the infrastructures of assessments itself should be changed or how our design of assessment should be rethought through as a result and also in the new environment of AI. And the same thing can be said of, I have the thought that's kind of overlapping with what Leanne shared is what type of capacity building we need to have for both educators and students so that I see moving forward one pillar of this work for both knowledge building and collaboration is we need to better equip our learners with new literacies, is in this case AI literacies, so that really hope to see AI making into the personal computing a bit more instead of being in the hands of tool developers or companies, so that the learners are experiencing and developing AI tools on their own to meet their very local needs, very specific needs as they work creatively with ideas. So I want to just conclude. I have a lot of questions, as you see. I would just want to conclude with a few more questions. which I wish to kind of continue to engage as we move forward. One is how can learning be reimagined with AI, and how to leverage AI capacities to augment human learning and knowledge building, and how do we democratize AI literacy so that AI becomes part of the personal computing and personal being. And I feel that's very important for me as an educator, and I hope to chat more with the panelists and everyone here. And that's all for me.
Thank you, Bodong. Bodong asked a very important question about how machine learning can augment human intelligence. I believe Mutlu actually will be talking a little bit about that. So without further ado, let's invite Mutlu to conclude their presentation before the Q&A. Thank you, Mutlu.
Mutlu, you're muted.
Mutlu, you're muted, Mutlu. You need to unmute yourself. Thanks.
Apologies, sorry. Well, one has to do it in every session, right? Wow, it's been really fantastic seeing colleagues' presentations. I didn't have the opportunity to see them, but it's so interesting and rich to see what's going on in the field. And in my kind of 10-minute slot, I tried to conceptualize and take a step back and try to provide some sense of richness of the field through 3 different conceptualizations of how we use and colleagues use in AI in education, mainly from human cognition point of view, and briefly give a few examples, but I will not get into the details as colleagues have already given fantastic examples. So my name is Mutlu CUKUROVA. I'm an associate professor at University College London, also currently the editor-in-chief of BJET. So I think in educational context, as must have already been clear, AI systems should be considered a continuum with regards to the extent they are decoupled from humans rather than only an approach to provide full automation, which is quite at odds in many other industrial setups. But I think in education, it's extremely important to conceptualize AI as a continuum. To me, AI can be used to externalize, internalize, and extend human cognition. And all of these different conceptualizations and implementations of AI have some potential to provide a significant role to provide support in teaching and learning setups. For instance, if we have a very clearly nominated output labels, enough and reliable amount of data, and if we are interested in operationalizing a particular task in a relatively stable and certain context, then we can use AI models to potentially automate a particular task. But in addition to this, as you might have seen in the previous examples as well, most often in an educational setting, AI models are actually used to help humans change their own operations of thought or representations of thought through internalizing some of the insights that come from AI models. Most good old-fashioned AI techniques that we are very frequently using in our systems that are transparent are used for these purposes of internalizing the model and improving our own understanding of behaviors and in learning and teaching setups. To me, at last, AI models can also be used to extend human cognition as part of a tightly coupled human artificial systems. And I think we are just scratching the surface in this space, but it's extremely important because I think this space has the potential to reach to a sum of intelligence that would be bigger than the sum of the human intelligence and artificial intelligence added up together. So just to give a couple of examples, with regards to these potentially fully automated systems, we have been working on designing a system that collects multimodal data, similar to the examples that colleagues have presented earlier on, that is collecting data from 2D and 3D video, from hand movements, gestures, audio. And in addition to this, we have been looking at the reflections on a mobile tool, trying to get some sense of the emotional states through static web data. I'm not going to get into the research details here, but I want to highlight that if we have very clear input data that we can collect from such a potentially stable environment, And if we ask researchers and expert teachers to give us clear output labels of what effective collaboration or what effective a successful task looks like in a particular situation, then this might be considered as a machine learning task where we have a clear input, clear output, and then it becomes a machine learning research where you're trying to build up and improve the efficacy and performance of a particular algorithm to be able to detect this classification problem or regression problem to solve this. That's really interesting machine learning research because most of the data that we are interested in is very noisy, so that creates on its own interesting problems. And also, most oftentimes in education, we don't really have very clearly nominated labels as our outputs. So that's an interesting space to explore. But from a research point of view, I think it's really important not to ignore this. These are highly automated, but low human agency systems, to me, in real world, has very limited value. But then, in other conceptualization, which is a lot more frequent in collaborative learning research and in our own research as well, we have been looking at those systems where we could build some models that we could present back to humans, and then humans could internalize the insights from these models to change their representation of thought. So this is one of the example contexts that we have been working on, collecting again multimodal data from students' face-to-face collaborative learning setups, then using these different input data with the help of AI algorithms and learning analytics methods. We have been trying to generate certain models of effective collaborative learning behaviors, whatever that might be. And in these kind of explorations, we typically explore statistical models, more semantically valuable structural models like epistemic network analysis, or more transparent and probabilistic machine learning models like hidden Markov models. The idea and the goal here is not to automate a particular task or not to particularly classify student groups into effective, less effective, medium effective competence groups. But here is the overarching purpose is to give us some insight into the complexity of learning processes that happens in complex collaborative activities. So these are some of the models that we have been building that shows the probability of moving from one particular collaborative learning activity to another. And we could observe different trends of collaborative learning behaviors that are associated with different learning outcomes or performance in terms of academic grades that students achieve. So we could actually have a look at these trends and provide feedback to students and open up these models for students and teachers to scrutinize them to improve their own learning behaviors. At last, I want to mention very briefly that AI can also be used in tightly coupled human AI systems. And these are not necessarily human-like systems, but they are human-centered systems. So they are not trying to focus on a task that a human would do and try to replicate it through the externalization of cognition, but they are human-centered that takes into account human factors that play a significant role in the use and adoption of these technologies. These systems aim to extend human cognition and augment their capabilities in educational settings and are very much associated with this idea of extended cognition, where technology helping humans become more capable. To be fair, I put an example from our own research, but when I saw Bodong's demonstration, I was just thinking that's a fantastic example of how potentially a fully automated AI taking a very small part of a large-scale learning activity and being part of the extended cognition of the learner and providing certain suggestions. So this is not necessarily to say that the example should look like the ones that we are focusing on, but we have been focusing on this computer vision dimension where we could detect students' nonverbal gaze and gesture behaviors to be able to automatically detect very simple engagement behaviors, whether they are engaged or disengaged or whether they are observing others or not, but then using these as input into transparent and scrutinable open models for learners and teachers to be built on top of the input as a transparent layer for people to keep their high agency and control over the final model itself. To me, we are just scratching the surface on this particular dimension in terms of these human-centered AI systems, but they are potentially the most likely the ones that would lead to some kind of capability and augmentation in terms of human cognition, and research from the learning sciences, research from the existing human-computer interaction literature should be used and built upon for us to be able to move towards how we could potentially adopt these technologies in real-world setups. Thank you.
Thank you, Mutlu. I think the panelists have actually, all the panels have actually provided some case example as well as the vision for the AI supporting collaborative learning, the high control, high automation coupling of AI and human being intelligence. Thank you very much for the panelists. And we shall now move into the Q&A session. And there's a question on WUVA. The question for all panelists is, AI is often used in quantitative analysis, but what about the use of AI in qualitative analysis? Do you have any response to that? Anyone?
Actually, sorry, should we raise our hands? I'm not sure how do we,
Oh,
how do you want us to?
Just feel free to speak, yes. Mutlu, do you have any response to the question?
I can have a quick go at this. Many thanks for this question. I think it's a really interesting one, and I do agree that perhaps by definition, in some of the approaches that we are using, we are moving towards generating measures that are quantified on terms that perhaps are not very easy to be quantified or would not even be possible to be quantified. And there is a significant challenge there. But I'm not really sure if I would agree that we are only looking at quantitative measures. Just to give a very quick example, in this example that I have mentioned, where we were looking at generating a model of particular behavior trends in a collaborative learning setups, most of the initial labels are actually coming from human researchers and or expert teachers watching detailed videos, trying to make qualitative judgments on certain behaviors existing or not, which by definition is providing some semantic input to these models before the modeling process takes place. But also there are colleagues, which is not my area of expertise, who are a lot more interested in techniques like natural language processing and trying to bring in a more qualitative analysis into educational setups. But I'm not going to comment on this because I personally am not looking at natural language processing myself.
Thanks, Mutlu. Any other responses for any other panelists? There are two other questions in the Q&A. If you can just click the button, you can probably see those questions. But let me just quickly go through one question. What opportunities and challenges do you associate with the agentive role of algorithms and AI in analyzing and facilitating or mediating asynchronous online discussion and debate? Opportunities and challenges. Bodong, do you want to answer this?
Yeah, I can take a stab at it. And yeah, this is a really wonderful question. In terms of opportunity and challenges, what I, from the education point of view, I think Mutlu, the way you framed it, I really appreciate the sophistication of how you framed AI control, human control, closely coupled and loosely coupled AI systems. And in the recent handbook chapter for the learning analytics, I kind of also reviewed a few tools and try to put them into different quadrants of that. So what I see in terms of opportunity is to exactly really borrow the idea you have, Mutlu, is, there are ways that AI can help the participants of a discussion, right? To summarize 100 different posts, or to summarize what has been discussed in the past 20 minutes in a debate. And also to, like Leanne also showed how to, extract those key concepts and attach some machine learned insights such as sentiment to those terms, which I see AI can be helpful and supportive. I see that opportunity is huge, and it's important for us to think about how that can be helpful for our design of the learning environment. In the same time, in my demo, I demonstrated a type of challenge, which is based on, if it's really only centering on the AI capability without thinking about human cognition, thinking about what's educational goal in that discussion and debate, then the use of AI is, I think, will become a lot of misuse in that case. So I'd say the challenge is to how to design the AI-supported experience of this discussion so that what we believe in learning and what we think about human cognition are not ignored. It's not only about how AI can do what they can achieve, but more what learners can learn from the experience. And then with AI, what else, how the learning experience can be further improved. So I'll stop there because I think this is a rich question that other panelists might want to jump in.
Right. Thanks. Any other responses? Julie?
I'm just going to build on from another angle. In our work with multimodal as well, I think we really value the teacher's interpretation of what we are presenting to them. So, of course, our work is very nascent, and we are really, like what Mutlu has very elegantly put together, that the fusion part, how the different data are interacting, and what can we tell of learning at that point. In fact, as the ongoing work from our research is to present this work to the teachers and to see how they looked at it, and sometimes even challenge their those experienced teachers, sometimes their intuition about what's happening in class and what they see, and helping us to interpret the data as well. So just wanted to add in that human factor from the teacher's perspective. But of course, moving forward, I think with analytics in the hand of the students, that would be a very powerful vision that we can see in our classroom, especially in Asian classroom. Yeah.
Thanks, Julie. There are two other questions. I think I'll just jump to another participant who asked the third question, because first two questions asked by the same person. So I just jumped first to the third participant. This question is about possibility of simulating the setting of collaborative knowledge building using AI. That means to use AI to predict how student collaborative learning co-occurs. Is it possible to do that?
Yeah, I would jump in and get started. I think it's an interesting idea to simulate collaborative learning with the AI, especially if we have some parameters that, as we think about small group discussion, for example, there are different modes of participation or different, even I'm hesitant to use personality, but, different dispositions in collaboration that students might bring in. So I see the possible value of using AI to simulate, if we bake some disposition in the AI that engage them in some conversation, maybe it can be an interesting way to understand the right composition of disposition and skills in a collaborative environment before actually going to the classroom. So I think it's possible. And then the next question is whether how meaningful that is. I think I need to think a bit more on that. Is I see we as panelists value a lot on human insights. What I see that's cutting across our work. So if we're purely kind of thinking about using AI for simulation, then what goals does it serve, and what is, where we put humans in the box? And I'll stop here.
Thanks, Mutlu. You raise your hand, Mutlu.
Yeah, thanks, Seng. I really want to follow up Bodong's point, really, and I do agree with the potential there. But it's an interesting question because, as we all know, researchers in collaborative learning, collaboration and collaborative learning occurs at multiple dimensions, at a very holistic, dynamic manner. And there are cognitive dimensions associated with collaboration. There are affective issues. There are metacognitive dimensions, looking at socially shared regulation of learning, for instance. So to me, simulating the setting of collaborative knowledge building using AI is, at least within the near future, is unlikely to be achieved at that level of complexity. But really interesting question to pose there is, do we really need, in order to be able to stimulate at least one particular dimension of collaboration with the help of collaborative knowledge building using AI? I'm not really sure if we need the whole complexity to be simulated for a human to take higher agency in the collaborative learning activities. And perhaps a cognitive dimension where an AI is providing semantically meaningful, coherent responses to particular posed inputs is not unrealistic at all. So what is the bare minimum is the core question there, rather than whether we could fully stimulate human level collaborative activity with an AI, from my point of view, in terms of teaching and learning.
Thanks, Mutlu. I guess a lot of AI researchers are thinking about how to predict the students' behavior in order to take actions or interventions. I think that probably is coming from the angle. Yeah, but I think the panelists do agree that there's a lot of importance about the human agencies as well, and how that can actually work in collaboration with the computer's intelligence, AI intelligence, machine learning. Yeah, I think, let me see, there are quite a number of things going on, including the chat. So I missed some of your very interesting entries here. Unfortunately, I think the time is now 7:59. I do see, Leanne, you actually responded earlier. Leanne, do you want to talk about your response to the first question? I missed that out. Sorry, Leanne.
Oh, that's okay. I'm a bit slow with the thinking, but I wanted to build on Mutlu's point. I was also thinking about what purpose the simulation can serve, and I think a good first step with AI and the AlphaGo is to simulate the way experts engage in problem solving and simulate historical examples of how we've seen design thinking in different contexts, different workplace and national context, to then think about how these dynamics unfold over time. And with regard to quantitative versus qualitative, I'm always going to be for mixed and for complexity and for multiple layers of analysis. And what I think is really neat about the opportunities with these digital technologies is that you're going to have multiple planes of analysis. You're going to have quantitative, qualitative, and then there's going to be a temporal dimension. And we can add in other dimensions to then add to the richness of analysis, which was what I understand is the goal of qualitative analysis. So I don't think that we would ever presume AI to have some dominant framework to then be prescriptive of all learning behaviors. And so we're still in the, I think most experts would say we're in the infancy of AI, how it can be used, how these algorithms can be developed. And so I think this is a great space to have that conversation and to build on what Bodong and Chee mentioned, to bring in students and educational stakeholders into the conversation so that we can redesign and move education forward together. Thank you.
Thank you, audience, for your wonderful questions, and thank you, more importantly, for all the panelists for your very insightful comments as well as sharing. I know there are more questions coming in, the more messages, but I think I'm quite mindful of the time. Now it's 8:01 over here in Taiwan, so we have exceeded by 1 minute. I know some of you have to attend another session, so we have to end here for this panel discussion. Once again, join me to thank the panelists. Thank you very much.